As we age, the cellular machinery that keeps us resilient begins to wear down. Tissues regenerate more slowly, immune defenses weaken, and DNA repair becomes less efficient. One of the most significant contributors to this gradual decline is cellular aging, a process driven by oxidative stress, inflammation, and telomere shortening. While no nutrient can fully stop time, an increasing body of research points to vitamin D as one of the most promising allies in slowing the aging process, particularly for those over the age of 50. Historically recognized for its vital role in calcium absorption and bone integrity, vitamin D is now emerging as a key regulator of genomic health and cellular longevity, especially in older adults. Why this age group? After 50, several factors combine to increase vulnerability. The skin's ability to synthesize vitamin D from sunlight declines dramatically, dietary intake tends to drop, and kidney function, which is essential for activating vitamin D, begins to diminish. At the same time, the risks of chronic inflammation, immune dysregulation, and diseases of aging begin to rise. This convergence creates a perfect storm where vitamin D deficiency becomes both common and consequential. One of the most fascinating aspects of vitamin D in older populations is its relationship with telomere length, the protective caps on chromosomes that shorten with each cell division. Telomeres act as internal clocks that limit how many times a cell can safely replicate. Shorter telomeres are associated with increased risks of age-related diseases such as cardiovascular disease, type 2 diabetes, and cancer. Several large observational studies, including NANS and the Nurses' Health Study, have linked higher blood levels of vitamin D with longer telomeres, suggesting that adequate vitamin D may help preserve genomic stability in aging cells. But how does vitamin D accomplish this? One of the primary mechanisms is its role in reducing systemic inflammation, a hallmark of aging often referred to as inflammaging. Older adults tend to have higher levels of inflammatory markers like C-reactive protein, CRP, IL-6, and TNF-alpha, even in the absence of infection. This low-grade, chronic inflammation damages tissues, accelerates telomere loss, and impairs DNA repair. Vitamin D, through its action on the vitamin D receptor, VDR, can suppress the expression of these inflammatory molecules and enhance the production of anti-inflammatory cytokines. In doing so, it creates a more protective environment for cellular longevity. In addition to inflammation, oxidative stress is a major player in cellular aging. Free radicals and reactive oxygen species, ROS, damage DNA, proteins, and cell membranes, contributing to age-related decline. Vitamin D has been shown to upregulate antioxidant defense systems, including glutathione production, thereby helping to neutralize oxidative threats that could otherwise degrade the genome and shorten cellular lifespan. What makes the case for vitamin D even more compelling in older adults is its impact on the immune system, which becomes less efficient and more dysregulated with age. Older individuals are more prone to infections, autoimmune reactions, and even vaccine failure. Vitamin D enhances the innate immune system, helping produce antimicrobial peptides like cathelicidin, and balances the adaptive immune response, reducing inappropriate overactivation. In doing so, it not only helps fight infections more effectively, but also reduces the chronic immune stress that contributes to cellular aging. There's also evidence that vitamin D interacts with cellular signaling pathways related to apoptosis and autophagy, two key processes in cellular maintenance and regeneration. By modulating these pathways, vitamin D helps remove damaged cells and supports tissue renewal, especially in high-turnover areas like the skin, gut lining, and bone marrow. Randomized controlled trials are increasingly supporting these associations. In older adults, vitamin D supplementation has been linked to improvements in markers of systemic inflammation, reduced fracture risk, better muscle function, and improved mood, all of which contribute indirectly to slower aging and a higher quality of life. One study, for example, found that daily supplementation with 2,000 IU of vitamin D3 was associated with less telomere attrition over 5 years compared to a placebo group. While telomeres are only one piece of the puzzle, they serve as a meaningful biological indicator of vitamin D's influence deep within our cells. The question of dosage is particularly relevant for older adults. Many experts now recommend 1,000 to 2,000 IU per day for individuals over 50, especially those with limited sun exposure or known risk factors for deficiency. Blood testing is helpful, as optimal serum levels for healthy aging appear to lie in the range of 40 to 60 nanograms per milliliter of 25 OHD. Importantly, this level is well above the outdated sufficiency threshold of 20 nanograms per milliliter, which was originally based only on bone health, not cellular resilience. Ultimately, vitamin D is far more than a simple bone-supporting nutrient. For those over 50, it plays a central role in maintaining genomic integrity, modulating inflammation, strengthening the immune system, and preserving cellular function in the face of aging. As the research continues to evolve, vitamin D stands out as one of the most accessible, affordable, and impactful nutrients available to support graceful, healthy aging. While no single nutrient can prevent the passage of time, ensuring adequate vitamin D levels, especially in later decades, offers one of the most scientifically grounded strategies to protect the body from the inside out. It's a reminder that the foundation of aging well often starts at the molecular level, and that even small daily habits, like a morning walk in the sun or a thoughtfully chosen supplement, can shape how we age for years to come.